Today we'll be talking on bisection method. The bisection method is a numerical method used to find the root of a function. You don't know what a function is. A function is a mathematical rule of process which is assigned to a unique value of x and what and y is assigned to x and a unique value of what y. It works by repeatedly dividing an interval a and b in half and selecting the subinterval where the function changes sign. In bisection method, in numerical analysis, we know that a numerical analysis deals with numbers. When we are solving a numerical analysis, there are some methods that we need to consider. We have bisection method, we have regular fancy method, we have Newton's method, and we have secant method. A lot of methods we can use to solve a numerical analysis. So today we are looking on bisection method. So in bisection method, there are some things that we have to know while using bisection method or to solve a numerical number, that is numerical analysis with what using bisection method. So in this place, it's telling us that we have to divide an interval, that is, we are by repeatedly dividing an interval a and b. If you have a function, you all know that if you have a function f of x, maybe f of x is to the power 3 plus 2x minus 5. For us to solve that, you know that is a function of s because s is what? S is that function, as s is to the power 3 plus 2x minus 5. It means what? You have to test. When s is 0, what do we have? When s is 1, what do we have? When s is 2, what do we have? So where it has a positive sign, so it means that's our what and what? That's our interval. That is our interval that we are going to consider. If you have an opposite side, it can be plus or minus. When we do s is equal to 1, if you do s equal to 0, we have negative. If you do s is equal to 1, we have positive. If you do s is equal to 1, we have negative as well. And if you do s is equal to 2, we have what? Positive. It means what? Minus and plus will come will be our what? Our interval, which is a and b. If it is minus and minus that come first, minus comes in second when s is equal to what? 1. We are not going to consider minus and minus. We have to consider minus plus is either minus plus, as you have to consider minus plus or what? Plus minus. So the opposite of minus is what? Plus. The opposite of what? Plus is what? Minus. So that is what is telling us that this is what we have to consider what it's work by repeatedly dividing an interval a and b in half and selecting the subinterval where the function changes sign, and is the opposite sign of the function. Steps of the bisection method. We have what? Choose an interval a comma b such that what f of a and f of b have an opposite sign. So if you choose an interval a and b, I've explained that one before, where we have our opposite sign, that is minus and plus or plus and minus if it repeats itself. If we have, when you consider it, if you have minus and next we do it, we have what? Plus. When we have minus and plus is our interval. So that's what we are calling our choose an interval a and b. So it will be our interval a and b. Then the next is what? To compute the midpoint. For us to calculate the midpoint, suppose our f of a is positive, our f of b is what? Negative. It means plus and minus. That's our positive sign and it's our interval. So we now divide what gives us plus and minus. F of a and f of b divided by 2. So it means we have computed the midpoint. Then here f of a, f of b must be what? Less than 0. No matter what it is, if you multiply f of a, f of b, your positive sign that changes, that is your interval. If you multiply it together, it must be less than 0. That is 0 must be greater than f of a and f of b. And next is what? If f of c is equal to 0, then c is the root. If f of c has the same as f of a, that is a is equal to c. So for us to get our root here, remember that bisection method is used to what? Is a numerical method used to find the root of the function. We consider bisection method to find the root of the function. For us to get our root of the function, that is our root. What we are going to consider is that when you are solving this, what give you the same answer? If you do x1, x2, x3, x4, if it is x2 and x3, you do x2, you get the same answer. Maybe it is 0, you do x3, you get the same answer. So x2 and x3 is what? Is the real root. That is the root. If you do s3, s4, s5, if s4 is 2.5, if s5 is what? 2.5 as well. So what gives us the same? will be our what last. So the variables is what s5. It must be the same. And if it is not the same, you will continue repeatedly until you get what? Until until the interval is sufficiently small. So you repeat the process until the interval is sufficiently small. Unless you are given to what? You have to stop at this, maybe approximate to what? 6. It means you are considering 6. If it is 5, considering 3. Watch the next video on how to solve what? How to solve a numerical analysis using what? Bisection method. Don't forget to subscribe to my channel. Whenever I upload a new video, you'll be notified. You can make a screenshot for this.